my dear physics students. Let us begin with numericals based on refraction of light through a lens. But before solving these numericals, what is important do you know? To understand sign conventions used for the lenses. Many a times children find difficulty in solving these numericals because they do not learn sign conventions. Without sign conventions, we cannot solve these problems. So my first job would be to teach you those sign conventions which will be helpful. Let us see how to use those sign conventions. Sign conventions basically for measurement of distances. Now we are going to talk about a convex lens. You know this is a convex lens. F1 and F2 are two foci of the lens. O is optical center, blue colored line is denoting object and red lines are denoting real and virtual image. This x dash is your principal axis. Now let us see how the sign conventions are used. Please check it. The first sign convention OF2 focal length f which is positive. Now my dear kids, what is the focal length for a lens? F2 is focal length for the lens. Where is F2 falling? F2 is falling on the right hand side, right? Right hand side from this O to F2. O is acting as origin on your graph paper. Try to make an analogy between this structure and your graph paper. O is your origin. On the right hand side, all distances are positive. Left hand side, all distances are negative. Above this x-axis, all distances are positive. Below the x-axis, all distances are negative. We all have done this in our coordinate geometry, right? While drawing graph. So ये OF2 जो है वो focal length है. वो कहाँ आ रही है? OF2 is on the right hand side. So obviously focal length for convex lens is positive. In textual language or in a theoretical language, I would say, distances measured in the direction of incident ray are positive. What do you mean by that? If suppose this is an object and incident ray starting from this object, isn't it? Incident ray object se shuru hota hai. And how is it going to go? It will go towards right hand side. So whatever you are going to measure in the direction of incident ray, that is from O to F2 in the direction, or in simple terms on the right hand side, those distances are positive. So OF2 focal length of convex lens is positive, right? Now we all know that object is always placed on left hand side. So object distance u will be always negative. Object distance कैसे measure करोगे? From O till object. Isn't it? O is acting as origin. So from O till object. That means, in other words, you are going against the direction of the incident ray, opposite to the direction of the incident ray. Incident ray ऐसे जा रहा था. अभी हम जो distance measure कर रहे हैं, that is from O till object, and hence U is negative, right? Now object हो गया. अभी ऑब्जेक्ट से हमें मिलेगी इमेज. ऑब्जेक्ट डिस्टेंस का लेटर क्या है? U. इमेज डिस्टेंस का लेटर आएगा V. अल्फाबेट में U पहले आता है, V बाद में आता है. ऑब्जेक्ट पहले आता है, इमेज बाद में बनती है. तो ऑब्जेक्ट पहले आता है तो उसको पहला लेटर U एंड इमेज डिस्टेंस के लिए लेटर है V. नाउ लेट अस सी हाउ अबाउट द इमेज. नाउ फॉर रियल इमेज, इमेज डिस्टेंस V इज पॉजिटिव. Why? Check it. Real image is getting on the right hand side. See, if this is the object and the rays are starting from the object and these rays are going to meet and going to form real image. Real image कहाँ मिलती है? कब मिलती है? Real image is formed when rays actually meet, and hence these rays are actually going to meet on the right hand side. So image distance V will be from this O till image. O till image. That means towards right hand side in the direction of the incident ray. So image distance V for real image is positive. Now how about virtual image? For virtual image distance V is negative. Why so? Virtual image. Can you see children the dotted line? It's virtual image. Virtual image always falls on the same side of the object. तो ऑब्जेक्ट कौन से बाजू में है? ऑब्जेक्ट इज ऑन द लेफ्ट हैंड साइड. वर्चुअल इमेज हमेशा ऑब्जेक्ट की बाजू में गिरती है. So this virtual image is on the left hand side from O. So image distance will be measured from O till this virtual image, from here to here. That is in the opposite direction of incident light. So obviously V image distance for virtual image is negative. Now let us talk about size of the object. Size of the object O is above the principal axis. ऊपर की दिशा में है तो साइज क्या होगी? पॉजिटिव. ऑब्जेक्ट हमेशा ऐसा रहेगा, उल्टा कभी ऑब्जेक्ट होता है? नहीं. बट इफ इट इज रियल इमेज, हाउ इज अ रियल इमेज? इन्वर्टेड, उल्टी है. सो रियल इमेज का साइज I विल बी नेगेटिव. वर्चुअल इमेज का साइज, वर्चुअल इमेज इज अबाउट द प्रिंसिपल एक्सिस. सो इमेज इज ऊपर, सो साइज ऑफ वर्चुअल इमेज इज positive. Please keep these points in mind. If you know all these things, problems are easy, cakewalk. Please remember. Okay. Now let us start with concave lens. You all are aware how does concave lens look. This is your concave lens. This is optical center. F2 is on left hand side. My dear children, please study concave lens thoroughly. You will understand focus of concave lens lies on the left hand side. It is because focus of concave lens is virtual. I hope you all must have studied it, right? And hence OF2 is our focal length, that is negative. Why? Because it is falling on the left hand side. As usual, object is present on the left hand side. So obviously object distance U, which starts from O till object, is always negative, right? Now size of object, object कहाँ है? Axis के ऊपर. So size of object O is always positive. Please keep it in mind. Concave lens gives you only virtual image. Please keep it in mind, only virtual image. Concave lens आपको real image देती नहीं कभी भी. So virtual image दे रही है. Virtual image always falls on the same side of the object. That means it is falling on the left hand side, and hence distance between O and this image, that is V, is negative. Now this virtual image I, that is size, is always positive. Why? Because virtual image is above the principal axis. So उसका size I कैसा होगा? वो भी positive होगा. So children, these two are sign conventions, convex and concave. You must know this, then only you will be by hearting the formulae, and then we all will be solving the numericals. Let us move ahead with the formulas. अरे बाप रे, नहीं एकदम easy है. Okay, the very important formula, lens formula, which talks about 1 upon V minus 1 upon U equal to 1 upon F. I hope you all are knowing what is U, object distance, what is V, image distance, and what is this small f, that is focal length. Formula क्या है? 1 upon V minus 1 upon U equal to 1 upon F. The second formula is linear magnification. हमारी image कितनी बड़ी होती है, how many times it is bigger or how many times it is smaller. To find out that, we have formula magnification. One formula is length of image, or you can say size of image, that is I, upon length of object or size of object, that is O. That means I upon O is one formula to get magnification. There is one more formula to find out magnification, that is V upon U. V is image distance, U is object distance. So I upon O as well as V upon U, both are the formulae for magnification. Third is पावर ऑफ लेंस. हम चश्मा लगाते हैं और चश्मे का एक नंबर होता है. दैट नंबर इज नथिंग बट power of the lens. This power is measured in unit called as diopter. Capital D is for diopter. The formula is power of lens is equal to 1 upon focal length in meters. Children, please keep it in mind. Power of lens is equal to reciprocal of focal length. But if you are going to find power of lens in diopters, that time keep it in mind, focal length has to be in meters. So these three are important formulae for your lenses. Now, with respect to magnification, we have to check on few things. Let us see that now. Linear magnification in detail. Magnification M is I upon O as well as V upon U. We know this. Now, expressions for magnification are same for both convex and concave lens. कोई भी लेंस होने दो, formula remains same. For real image, how is a real image, children? वो उल्टी होती है, inverted होती है. So obviously for real image, size of image I would be negative because it is inverted. So this magnification will be negative. So whenever you get magnification negative, जैसे आपको मिलता है -2, m equal to -2, उसका मतलब है image is inverted and inverted image is real image, right? Now, if image is your virtual means it is erect, it is upright, it is above the principal axis. So size of image I will be positive in that case, isn't it? Object का size तो हमेशा ही positive होता है. Object हमेशा ही axis के ऊपर होता है. So if you get magnification positive, that means image is virtual. Please keep this in mind. A convex lens can have value of m positive as well as negative. क्यों भाई? Because convex lens gives you real image as well as virtual image. You please go through your ray diagrams. There is one case in convex lens where you are getting virtual image. My dear kids, please open the book, check the ray diagram. Which one? I will tell you. Where object is placed within the focal length. ऑब्जेक्ट को OF1 के अंदर रखा है. जब ऑब्जेक्ट फोकल लेंथ के अंदर रहता है, फॉर कॉन्वेक्स लेंस यू गेट वर्चुअल इमेज. Otherwise, convex lens is giving you real image. Real image is always inverted image. So for that, we will get magnification negative. But there is one case where you are getting image is virtual. That time, magnification will be positive. But if it is concave lens, then I have already told you, concave lens gives you only virtual image. And for virtual image, that is for upright image, magnification has to be positive. Please remember all these sign conventions. One more thing which is very important with respect to magnification. Let us see that. This is the formula of magnification. Now we know I upon O as well as V upon U. Now please see, if you get magnification greater than 1, image is magnified. मतलब क्या? If suppose I get m equal to -2, आप क्या बोलोगे? -2 है भाई, एक से छोटा है. ना 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 ना, -2, माइनस को बाजू में रखो. माइनस साइन, नेगेटिव साइन इन मैग्निफिकेशन इज टेलिंग अस इमेज इज इन्वर्टेड. अभी देखा था कि मैग्निफिकेशन नेगेटिव आया, मतलब इमेज कैसी है? इमेज इज इन्वर्टेड. बट दैट टू नंबर मैग्निफिकेशन इक्वल टू -2, I said that 2 number is telling me magnification is greater than 1. That time I would say image is magnified, and if it is -2, image is real, inverted and magnified. Okay. Now, if magnification is equal to 1, then size of object and size of image both are same, because I upon O, if size of image is say 2 millimeter and size of object is also 2 millimeter. 2 upon 2 क्या आएगा आंसर 1. So if magnification is 1, then size of object and image both are same. Let us move ahead. If magnification is less than 1, then what? Then image is diminished. If you get m equal to plus half 1 by 2, 1 by 2 is less than 1. So this plus will tell me image is erect, upright. That means it is virtual. But 1 by 2 less than 1, image is diminished. So if you remember all these things, I will tell you, you will get good marks in this particular part of the numericals. Do not skip this. Fine. Let us see further. M is always less than 1 for concave lens. क्यों बोला है ऐसा? M is always less than 1 क्योंकि concave lens हमेशा diminished image देती है, छोटी सी image देती है. So, छोटी सी image, diminished image, that means M will be always less than 1 for concave lens. While it can be greater than, equal to or less than 1 for convex lens depending upon position of the object. हमारी जो convex lens है वो हमें कैसे कैसे images देती है. Either it will give you bigger image, so it will be magnified, means m will be greater than 1. हमें यही convex lens छोटी image भी देती है, diminished image भी देती है, that means m is less than 1. एंड यही कॉन्वेक्स लेंस हमें मैग्निफिकेशन इक्वल टू 1 मतलब ऑब्जेक्ट साइज एंड इमेज साइज सेम ऐसी भी केस देती है. सो मैग्निफिकेशन कैन बी ग्रेटर देन 1, कैन बी लेस देन 1, कैन बी इक्वल टू 1 फॉर कॉन्वेक्स लेंस. I hope all these things are clear to you kids. Can we start with the numerical? Okay, please prepare this, and of course I will upload new video for you for the numericals. Stay tuned with Wakankar Group.